Khushboo Arora, and I'm here to describe about a machine learning project that I recently did on NLP, that is natural language processing. We all know that data exists in structured as well as unstructured form. So we have text files, flat files, Excel, etc. that falls into the category of structured data. And then we have comments from social media like Facebook, Twitter, maybe product reviews that the customers have given, or maybe recorded voice calls about the customer service, etc. All of these falls into the category of unstructured data and needs to be analyzed too. So here in my project, I had around the TensorFlow recently launched a speech recognition data set wherein 65,000 1 second words, 30 short words were there which were uttered for around 1 second or maybe less than 1 second too. There were 65,000 words which need to be modeled and recognized through machine learning itself. So yeah, so I had, since they were, all of these were audio files which had an extension of .wav. So loading them into Python, that is the Jupyter notebook that I used, was itself a task, and I initially faced a lot of problem with that too. So then Librosa was the library that I used to load these audio files into my Jupyter notebook. After a lot of hustle bustle, I made it through. So then after loading these files, I also went through a lot of concepts like amplitude, wavelength, etc. in order to properly analyze the graphs of the data that I would get in when I would plot these audio files. So yes, I did go through the concepts of the same. Then after loading the libraries and making the data read into my Jupyter notebook, I plotted a spectrogram, which is basically a 2D plot between time and frequency, and it gives us colors like yellow, blue, green. Since I have 65,000 words, 65,000 1 second, 30 words, so different colors occurred in that the plot of the spectrogram. You could read about spectrogram more and maybe get an idea about it. So after plotting a spectrogram, I got a rough idea of what these short words, the frequency of these short words is, the amplitude, etc. Then I moved further to analyze a little more, do a little more of data exploration maybe. So then I after plotting, I got number of recordings that were there per words, like how many times the word up is being spoken or maybe yes is being spoken. Then one more plot which I did was the duration of these words. Like there were a lot of words which had the time duration of less than 1 second. 1 second. So it was of no use. These words were of no use. So I resampled the data, which from 16,000 hertz to 8,000 hertz, and I had two options in order to deal with these words. Either I could remove them or I could resample the words, right? So instead of removing these words, I resample them to 8,000 hertz. So after resampling these words, I moved on to since it was a multi-classification problem, I had in mind that convolutional neural network could be applied in order to model these voice as in words. So yeah, for this I had to use the one hot encoder, which is basically used in multi-classification problem. But yeah, before that, after I removed the words which were less than 1 second, I was left with certain amount of words. Then I converted these words, which I call them as tokens, to integers, because that is how these words are being read into my Jupyter notebook, and that is how the machine understands. So after converting them into integers, I use one hot encoder to convert them into ones and zeros. Since I told you that it was a multi-classification problem, like in logistic we just have binary, it's either 0 or 1. But here we have, like say suppose 10 words, so I'll have 9 zeros and 1, and accordingly whatever the word is. So one hot encoder basically gives you a set of matrices with zeros and ones that are being converted from the integer values. So after I had the one hot encoder encoded values, I converted all of these 2D format arrays into 3D because convolutional neural network just reads only one dimension, as in all of them converted into a uniform dimensional data. So I converted them into 3D, one hot encoded values into 3D values. All the data I had was in three-dimensional form. So then, yeah, comes the modeling part. I divided the data set into train and test. Then after dividing, I had stratified, a lot of mix and match, all that I did, because I was, yeah, really facing problem with dividing the data set into train and test, because it was the integers that were encoded, and my y was also different. Y was the words that I would be deciphering, right? Like the word spoken is yes or the word spoken is down, that had to be predicted. So yeah, after dividing the data set into train and test, I chose around sample of 32 words. Yeah, trained on a batch size of 32. I used that. So after training the model on batch size of 32, I got a certain amount of result. And yeah, for convolutional network, the code comprised of conv 1D, that 1D, that is the dimension that is specified, then the flat layer that is there, then dense layer. All of this one can definitely go through and study about, and get an idea of what convolutional network actually is. So after reading about convolutional network, I actually, then only I could apply convolutional network, because I wasn't able to understand the results initially. So yeah, convolution network, after applying the convolution network, and then plotting the diagnostic plot, wherein I got that what is how much the train and test values are actually lying upon each other, and what is the difference. Are these predicted values really close to the target values or not? The diagnostic plot helped me show that. So yeah, it was a pretty decent result. The plot showed me pretty decent result between train and test. And so after that, one could also do was, one that you can record your voice, and that the audio file will be again in WAV format, and load that file into the Jupyter notebook and test it accordingly, because we got the model finally. And to test it, one could use their own voice, I mean any short word that he wants to utter, and record it, and save it in WAV format, and then predict it, because yeah, the model was built and one could easily test it. Although I did not record the voice, but yeah, it is easily doable. The one problem which I faced with convolutional network was that it took a lot of time. I mean, I just left it. I did it in the evening and left it. I don't know, for around 1.5 2 days, and my system was also, the tabs weren't opening. The system was also going on hang mode a lot of times. I had to shut down all the other tabs, and then it was running. So yeah, because neural network does take a lot of time, these GPUs that are being invented specifically for neural network, and not CPUs. So yeah, it took a lot of time, but then after applying all of these models, and studying about NLP, going through the concepts, this project gave me really a good insight of what NLP is. And I think customer sentiment analysis in the banking domain is what I see as a most upcoming field and upcoming application that banks could really use in order to analyze customer service calls, and maybe make changes in the services or product, etc. And the comments in social media can also be analyzed to generate a lot of data, and put to use. So yeah, that is what my project comprised of. Thank you.